Okay, today the paper number 8, let's see, 8. Right, its first question sketch in the same diagram the graphs of y half mod x minus 1 and y mod x minus 1. Hence, otherwise, find all real values of x which satisfy the inequality this. Right. Now, first we'll draw this graph y equals half mod x minus 1. When you define the mod x minus 1, it changes at 1. On the right of 1, it is x minus 1. Left of 1, minus 6 plus 1. No? On the right, we have to take this. On the left of 1, this should be multiplied by minus. Then on the right of 1, this graph is going to be half x minus 1 mod is x minus 1. No? This way. Half x minus half. On the left of 1, y equals half minus 6 plus 1. No? Y equals minus half x plus half. Right. I will draw this diagram. This way we can draw it. Suppose 1 here. Right hand side, we have to draw this, no? Half x minus half. Right. When we put x equals 1 here, y 0, through this point it passes. The intercept is minus half. Minus half I take somewhere here. Then we have to join these 2 points. You see? And the line should be produced this way. This is the required line. On the left of 1, right, minus half x plus half. When x equals 1 again, y 0. Right, starting from here, the same half we have to take here. Then we have to join them. Is the graph. This half. The y-axis. Right, no? Secondly, ask it to draw y equals mod x minus 1, no? Mod x minus 1. That means mod x graph is this way, V-shaped graph, no? At the origin. Since we have subtracted 1, we have to bring this overall graph downwards by 1 like this. That graph only we have to draw here. Then it passes through minus 1. So half, another half we have to take here. Minus 1 is here. Right, so then this changes at 0, no? On the right of 0, mod x is x. Right of 0, what we need to draw is x minus 1 graph. Right? X greater than or equal to 0. In that interval, this is the graph we have to draw. X less than 0, the graph we need to draw is minus x minus 1. No? Yeah, here when we put x equals 1 by 0, the graph passes to the point this. And intercept is minus 1 here. Through this point it passes. So then I can draw that graph like this. Join this and this and produce the line. You see? produce the line. Right. This graph has the equation y equals x minus 1. The other one, also people, when you put x equals 0, y minus 1, that passes through the point 1 here. You see. Will produce this way. And this is that two graphs. Here minus 1. Right. The equation of this is going to be this on the left of 1, y equals minus half x minus half x plus half. And this equation is y equals half x minus half. Right. And the equation of this y equals minus x minus 1. Let us take this point as A. What point is? Its exponent I am going to find here. That we can find by solving this and this simultaneously. Right? Okay. Now if I solve that, minus half x plus half is equal to minus x minus 1. Bring this side, plus x minus half x means x by 2. Take this right hand side, minus 1 minus half. X by 2 is minus 3 by 2. Cancel down. X is minus 3. Here minus 3. Okay. Right, we do that. Now, hence or otherwise, given, hence or otherwise, find all real values of x which satisfy the inequality this. Right. Now, we can come to the next part, then like this. The given inequality is x minus half greater than mod 2x minus 1. People, I am going to substitute here t equals 2x. T equals 2x means x equals t by 2. Like this. Then what do you get here? X is t by 2 minus half greater than 2x is t mod t minus 1. This 2 is positive, we can take that out from the mod sign. We get this. Like this we get. Okay. Now first we will find this t which satisfy this. To get that answer, we can use now the graphs. Once you for a while think this t as people just u or x again, you can see half mod x minus 1 greater than mod x minus 1. That means this interval we can find by using this graph. Then the black graph is the half mod x minus 1. That is required the interval of x, that black graph is greater than the red one. By the diagram you can see the black graph is greater or above the red one in the interval from minus 3 to 1. So therefore this happens when t less than 1 and greater than minus 3. Right here you can see The black graph is above the red one, between 1 and minus 3. Okay. Right. Now we'll convert this t. T is really 2x. No, put here 2x. Right. Now divide by 2. Then we get this way the answer. Then the required answer is this. X is less than half, greater than minus 3 by 2. Okay. Right. First question is that. Question number 2, second. Question number 2. Right, given this way, limit x going to pi. Limit x going to pi. Right? X going to pi. 1 plus cos cube x. 1 plus cos cube x and root 3x minus root 3 pi divided by sine cube x. Right? Okay. Now I can take here limit x going to pi. The 1 plus cos cube x, this 1 I can write as 1 cube. 1 cube plus cos cube x. Consider that as a sum of 2 cubes we can factorize. So what is the first factor? 1 plus cos x. Second factor 1 squared minus product of these 2 and square of this. This way. And to eliminate this, we multiply numerator and denominator both by conjugate of this. Conjugate of that. That is root 3x minus root 3 pi into root 3x plus root 3 pi. By this we multiply both the numerator and denominator. Okay. As sine cube x we have. That sine cube x we write as sine x into sine squared x. Here we can write sine squared x. But this sine squared x we can write as 1 minus cos squared x. That 1 minus cos squared x we can write as 1 minus cos x, 1 plus cos x. Understood? Right. Then I write that here. 1 minus cos x into 1 plus cos x. Correct, no? These two you can cancel down like this. Right. Now, here we can simplify this. When you simplify this, what do you get, people? A minus b, a plus b. Then square of this minus square of this we get. 3x minus 3 pi coming. Take 3 out. This is x minus pi. Okay. Now what I do next is this. I write the limit, it's going to pi, this thing, 1 minus cos 6 plus cos squared x. That, correct. Next one. People, this 3, I write before, that means here. And now this x minus pi, I take, it is at the numerator, no? We take that below this denominator, under this sin x, like this. Sin, I take x minus pi. I write this x minus pi as pi minus 6. Then you know minus sign coming out. That minus sign I write here. That x minus pi, no, that I wrote as pi minus 6. And here we have minus sign. And this sin x now we must write. This sin x I write as sin pi minus 6. Sin pi minus 6. You know sin 180 minus 6 is sin 180 minus 6 is sin x. Second quadrant, no, second quadrant sin positive. Alright, that is okay. And now we have people this one, right? That also I am going to write like this. Root 3x plus root 3 pi, like this, huh? I write. Now we can see, right? We can see now. Another one part I missed, no? 1 minus cos x I must write. This is right. Now what I do next is, people, this I apply limit x going to pi for this, and this separate, and for this also. You know, when x going to pi means the pi minus x difference is going to 0. Then here we have sin theta by theta. Then I can write now like this. Limit x going to pi 3 times 1 minus cos 6 plus cos squared x. Right. This one, the minus sign, I write here now. And this I write limit pi minus x going to 0. That's also correct, no? Correct, no? X going to pi means the difference between x and pi is 0. Right. So then sin pi minus 6 divided by pi minus 6. Then what do you have here? Sin theta by theta, theta going to 0. Right. Here I put limit x going to pi 1 over root 3x plus root 3 pi. And here limit x going to pi 1 over 1 minus cos 6. Right. Now we can put here. This is really 1. Here now we put pi here. Right. Cos pi, cos 180 minus 1. Here cos 180 minus 1 squared plus 1. 1 plus 1 plus 1. No? Right. So then we get minus 3 here. This bracket 1 minus 1 minus 1 squared divided by, this is 1 into here 3 pi root and 3 pi root. What is that? 1 over 2 times root 3 pi. And here 1 minus 1. Okay. Now what do you get here? 1, 1, 1, 3. Minus 3 times 3, 1 over 2 root 3 pi, and here plus 2. Correct, no? Right. Now we must get a negative sign there, people. This root 3 and this we can cancel down. We get 3 root 3 with minus sign. 4 times root 5. Right. Minus 3 root 3 divided 4 times root 5. This now we take that answer. Right. Okay, next one. Third one. Right, no? Okay, so that the equation of the perpendicular drawn to the hyperbola xy equals 16 at the point P, 40, comma 4 over t in the first quadrant, right? The point P is in the first quadrant, so therefore the coordinates of point P should be positive. Okay, the hyperbola, right? Xy equals 16. You know, to sketch this one, we can take this idea. Hmm? Y equals 16 over x. When this x goes to positive infinity direction, is fraction going to 0? When x coming towards 0 through positive values, y going to positive infinity. Ah, yes. Graph is this. Similarly, when x going towards negative infinity, the fraction going to people 0 through negative values. X going towards 0 from negative values, this is going to negative infinity. The graph is like this. It's how we roughly sketch the graph. Okay, this is a hyperbola xy. Right. Now there's a point in the first quadrant P. It is 40, comma 4 over t. This P is in the first quadrant. Therefore, the both coordinates should be positive. For that, P must be positive, no? Right. P is positive. Otherwise, the point P cannot be in the first quadrant. Xy equals 16. Right. Now, at the point P, a perpendicular is constructed. First tangent we draw like this. Perpendicular means the line perpendicular is tangent. It is like this. Okay. Then first I am going to find the gradient of this by differentiating that. Okay. We can differentiate this u into v form. X times dy by dx plus y times 1 equals 0. Dy by dx is therefore minus 1 over x. Now we can write dy by dx at the point P. Put in y, x coordinates of the point P. Y coordinate is 4 over t. X coordinate is 40. Cancelling these two, we get minus 1 no t squared. That is the gradient of the people tangent here. Now we need to find the equation of the perpendicular, no? Then you know the gradient of the perpendicular can be obtained how? By taking the reciprocal and multiplying by minus sign. Gradient of the perpendicular. Gradient of the perpendicular. Going to be t square. Right. That perpendicular, if I draw, suppose it is like this. Its equation only now asking. Now you can write its equation by using y minus y naught equals m times x minus x naught. Y minus y naught is the y coordinate of the point P. 4 over t. Now the gradient we found, t squared, x minus x naught is 40. This way we can write. Now, by multiplying by t both sides, you can take the answer yt minus 4, here t cube x, no, and t cube minus 40 means 4t4. Take this all terms right hand side, then we get t cube x minus ty, take this right hand side, 4, and here this 4 we can take out, 1 minus t4 equals 0, right? Here again when you take minus sign out, okay, then the given answer come in, right? Okay, that way you can take the answer. T cube x minus ty minus sign take out t4 minus 1 equals 0. Right. Okay, now we are given next like this. Yeah. If this perpendicular passes through the origin and meet the hyperbola at Q, this passes through the origin and meet the hyperbola here at the point Q. This is the point Q. People, then here for the point Q, we can suggest coordinates. See here, point P, we wrote 4t x coordinate, y coordinate 4 over t. Then point Q also another point of the same hyperbola, no? Then its coordinates x and y we can write in the same way. This t will take different value for the point Q. Then I'll take the value to get this point Q which we have to substitute for this t is capital T. Then I can write the coordinates of Q how? For capital T, comma 4 over capital T, like this. Alright. Now to find the point Q, we should find this T, capital T. Now first we are given this perpendicular passes through the origin. That means 0, 0 is on this line. That means when you put 0 and 0 for x and y, this equation must be satisfied. We can put x0, y0. This both will be 0. Then we get minus 4 into this equal to 0. That says t4 minus 1 equals 0. This gives us t4 equals 1, t equals plus or minus 1. But we told people here P is in the first quadrant, T should be positive. Therefore, out of this 2, we take plus sign. T greater than 0, therefore T equals 1. Right. Now, how to find this capital T? Yes. We know, people, here the gradient of this perpendicular, we found T squared. Now we know the value of T. Therefore, the gradient of this line perpendicular we found as T squared. Now we know T as 1. Then the gradient here is T squared, 1 squared, 1. And this coordinates also now we can write because T equals 1. Then the point P is really put T1 here, 4, 4. Right. Now to find the capital T, we can write the gradient of this PQ line using this coordinates and this coordinates. That gradient we can equate to people 1. Right? Now we can write PQ gradient M PQ is equal to 1. How to write the gradient? Difference of y coordinate. 4 minus 4 over t. Difference of y coordinates divided by difference of x coordinates. 4 minus 40. Difference of y coordinates divided by difference of x coordinates is a way of finding gradient. This is equal to 1. Then we can cancel down numerator and denominator by 4. Here 1, here 1. Then we have what, people? 1 minus 1 over t. 1 minus t equals 1. Correct, no? Then we get this use the cross multiplication. 1 minus 1 over t equals 1 minus t. Okay, these two you can cancel down. Then we get people minus 1 over t is equal to minus t. Again minus signs cancel down. Use the cross multiplication. T squared equals 1. T equals plus or minus 1. T equals plus or minus 1. Definitely t equals plus 1 is not possible because t plus 1 corresponding to the point P. Therefore, t should be minus 1. That's also true because Q is in the what quadrant? Third quadrant. Third quadrant, both x and y should be negative. Therefore, t must be negative. Therefore, t we select as negative 1. Now we can write, what is people asking the coordinates of Q. You can write, therefore, Q substitute for t minus 1, minus 4 and minus 4. Q is minus 4, minus 4, right? This way we can take that. Question number 4, the next. Right. Question number 4. L1, L2, two lines given us. This is suppose the two lines. L1 line, x plus y minus 1 equals 0. L2 line, 3x plus 4y minus 2 equals 0. 3x plus 4y minus 2 equals 0. Right. Two distinct points A and B are situated on L1. Right here. Suppose A. Other point is here. B. The perpendicular distance from each point to L2 is 2 units. We'll draw perpendicular like this. You see? 2 units. Here also 2 units. Asking what? Find the coordinates of A and B. Yes. Now I can write here the coordinates of A. Right, people now see here, if I assume the x coordinate of A as t, y coordinate of capital A we can find here. Put x coordinate t here. That t and this minus 1 when you take to right, take minus 1 to right as 1 minus t. 1 minus t. Right. When we assume the x coordinate of the point capital A as t, people, the y coordinate come in as 1 minus t. Correct, no? We can put here t, take that and this minus 1 to right hand side, 1 minus t. Now, the perpendicular distance from this point A to this L2, we can write by using that formula. How to find that, people? That can be found. This x and y coordinates, we substitute for x and y in this left hand side, and we take modulus. 3 t plus 4 times y, 1 minus t minus 2 modulus. And it is divided by the square root of x coefficient 3, it's perfect squared, y coefficient 4, perfect squared. This. Now, this is equal to the distance 2. Right. What is this? This is 5. Use of cross multiplication. And meantime, since here 3t minus 4t minus t. Here 4 minus 2. It's 2 modulus. here 5 into 2, 10. Now remove the modulus, put to right plus or minus. Now take plus sign separately, minus sign separately, and take two answers. We get two answers because of what, people? Because of there are 2 points on the line L1. They are the points A and B. Right? Okay. Now we can take plus sign. Right. Then we get minus 2 plus minus 3 plus 2 is equal to plus 10. Take this side, this side. Then we get t minus 8. And minus sign, minus t plus 2 is minus 10. Takes this n, is this t 12. There are two answers. So therefore, taking any t value and substituting here, we can find A. Other t value we get B. Therefore, we'll take A. Right? T put minus 8. Minus 8. And here when you put minus 8, 9. 1 point is minus 8, 9. Other point, 12. 12. 1 minus 12 minus 11. So these are the points. Correct, no? Minus 8, 9 is. Right, question number 5 next. Question number 5. Right, cosec theta plus cot theta, we have to prove equal to cot theta by 2. Right. Now cosec theta we can write as 1 over sin theta. Cot theta cos theta by sin theta. Now take common denominator as sin theta. Numerator now 1 plus cos theta. Sin theta I can write by using the half angles, 2 sin theta by 2 into cos theta by 2. This cos theta we write using half angle formula, 2 cos square theta by 2 minus 1. This 2 you can cancel down. Then we have this divided by this thing, no? Other 2 we can cancel down with this 2. 1 cos theta by 2 term we can cancel down completely with this. Now what do you have? Numerator cos theta by 2, denominator sin theta by 2. So we get cot theta by 2. Right. It is the left hand side, cosec theta plus cot theta. Okay. Right. That way we can take the answer. Right. Now first part we prove. Right. Now second part I can take like this. By this proof, I take this cot theta to right hand side. Okay, I take that cot theta to the right hand side. And we subject cosec theta. Now cosec theta is equal to cot theta by 2 minus cot theta. Right. Now what we do is this. Now we substitute for theta. Right. Put theta here 2 pi by 15. Not pi by 15. This is an identity, no? So any value of angle theta, left and right are equal. Then I first put pi by 15 for this cosec this theta. Then we get cosec pi by 15 is equal to cot pi by 15 into 2 means pi by 30 cot pi by 15. Secondly, theta 2 pi by 15. Then we get cosec 2 pi by 15. Here we get cot theta by 2, no, pi by 15. And cot 2 pi by 15. Secondly, I put theta 4 pi by 15. We get to the left hand side cosec 4 pi by 15 cot 2 pi by 15, no, minus cot 4 pi by 15. Correct. Finally, we put for theta 8 pi by 15. Then we get cosec 8 pi by 15 equals cot 4 pi by 15 minus cot 8 pi by 15. Now what we do next is, people, the left and right we add. That means this way we write it. Right. Then in the left hand side you get the sum of these 4 terms, right? Cosec pi by 15, cosec 2 pi by 15, cosec 4 pi by 15, cosec 8 pi by 15. People, when you at the right hand side, yes, all terms, right, we must write along a line, no? Then what happens is, this is cot pi by 15 with minus, this is with plus. These two will cancel off. Then the cancellation we can do here itself. Here minus cot 2 pi by 15, to that we add cot 2 pi by 15. These two will cancel. Similarly, these two will cancel off. Then without cancelling, the terms remaining are this and this only. Then what do you get? Cot pi by 30 minus cot 8 pi by 15. This is what we get last. Now this only we need to prove equal to 2 cosec pi by 15. Let's see how to prove that. Okay. Now I can prove it like this. Right. Right. I put equal sign here. Cot we can write. People, cot we can write cos by sine. Cos pi by 30 divided by sine pi by 30 minus cos 8 pi by 15 divided by sine 8 pi by 15. Correct, no? Now we will take product of these two as a common denominator. Then what do you get? Sine pi by 30 into sine 8 pi by 15. This comes here, this goes here. Then we get sine 8 pi by 15 into cos pi by 30 minus cos 8 pi by 15 in sine pi by 30, like this. Then see, people, you can see in the left numerator you have, it is of the form sine A cos B. minus cos A sin B. Sin A cos B minus cos A sin B. It is sin A minus B. So then I can write the numerator sin 8 pi by 15 minus pi by 30. Right. Denominator we have a product. Now this is what I do. This denominator I multiply by 2. And to balance this, the numerator also I multiply by 2. Right. Now we'll simplify here. When you take the common denominator as people 30, this should be multiplied by 2. 16 pi minus 5 divided by 30. 16 pi minus 5 is 15 pi divided by 30. 15 and 30 when you cancel down, we get pi divided by 2. Numerator. 2 sin pi by 2 divided by, right, now. Here for this we apply people, you know 2 sin A sin B formula. In trigonometry we learned under product formula. 2 sin A sin B formula. Can you remember this? This is cos A minus B minus cos A plus B. Now we apply this there. Now what do you get there? Cos A minus B, pi by 30 minus 8 pi by 50 minus cos A plus B, add these two angles, pi by 30 plus 8 pi by 15 like this. Correct, no? Then here sin pi by 2, people 1. Right, people, now you can see the same difference, no? Same difference of the angles here we have. This difference only we notice as pi by 2. Then this difference should be what? Minus pi by 2. Understood? So therefore I am not going to explain the way of coming here, minus pi by 2. Huh? Then we get the next line. Numerator 2, because sin 90 is 1. Here we get cos minus pi by 2 minus cos. Here, take the common denominator as 30. Then, this should multiply by 2, 16 and 1, 17 pi. This way we get. People, you know, cos minus pi by 2, we can ignore this minus sign. Cos pi by 2, this is 0. Now we have 2 over minus cos 17 pi over 30. Okay. Now this 17 pi over 30, I can write like this. 2 divided by cos pi by 2 plus pi by 15. See here. When you simplify here, 2 and 15, when you multiply we get 30. This 15 come in here, 2 come in here. 15 pi plus 2 pi. 17 pi, this is coming. Alright. Then this 17 pi over 30 angle here we have. Now assume this pi by 15 as theta. Cos 90 plus theta form here we have. Cos 90 plus theta is people minus sin theta. Then we can write this as how? 2 over this minus sin. Cos 90 plus theta is minus sin pi by 15 like this. Here minus when you multiply we get plus 2 over sin pi by 15. Alright. This denominator sin pi by 15 means 1 over sin cosec. Then we get 2 cosec. 2 cosec 5 by 15. Right. So that means, people, when you simplify this, that is the way of getting this answer, right? Correct, no? Yeah. Right. Now, the view part over. We can go to the applied part. Right. Right. Now, number 6. Two balls A, B of masses 4m, m. 4m and m. Right. Are placed on a smooth horizontal table, and the ball A is given speed u such that it collides with B. If the coefficient of restitution between the balls is e, show that the speed of A after collision this much. Further, if the speed B after collision is twice that of A, show that E equals 2/3. Right. We'll see how to take this. This way we are given A, B, O, M, moves with velocity u, M, B. After collision, let us take the velocity of A as v1, B as v2. Now we apply conservation of linear momentum rightward. After the impact, total momentum is this, should be equal to momentum before impact, m. You can cancel down for v1 plus v2 for u, number 1. Newton's law of restitution, we apply rightward. It says minus e times relative before impact. Before impact B rest, then A moves with u, that is the velocity, relative velocity, relative to B. After impact, we need to find the velocity of A relative to B. That means we have to stop B. Apply leftward v2 on B and on A. Then B at rest, A will have rightward velocity v1, applied velocity v2 leftward. Then the resultant velocity of A rightward going to be v1 minus v2. Number 2. Right. Now, we can first find by adding this 1 and 2, these 2 will cancel off. By v1, take the u out, 4 minus e times u, subject b, u by 5, 4 minus c. Right. Secondly asking, what people? Secondly asking, further, if the speed of B after collision is twice that of A, right? We are given v2 given as 2 times v1. v2 given as 2 times v1. Right. We are given v2 equals 2 times v1, no? Right. v2 equals 2v1 given. Then what we do is this, people. In number 2, I substitute this v2, that 2v1 by 2. By 2 you can write v1 minus v2 is 2v1 is equal to minus vu. This is minus v1 is equal to minus vu, minus signs you can cancel down. Now substitute v1, this answer. U divided by 5, 4 minus c equal to now eu. We cancel this minus signs. This way you can cancel down. 4 minus e is equal to 5e, no? This is right hand side. Okay. Equals 2/3. You get the answer like that, huh? Right. Number 6 is that. Number 7. Yes. Number 7. Ball drop from a plane flying horizontally with speed u r, right? Then when the bomb is dropped, its velocity horizontally, the velocity of the plane. It has no initially vertical velocity because plane is moving horizontally. Then the velocity of the plane only the bomb gets at the moment it is released. Then at t equals 0 or when the bomb is released, it is moving horizontally. Understood? Right? Now, vertically below this, right? At the height h, the airplane is moving. This way, a particle, another, projected. A ball is thrown at an inclination alpha to the horizontal. This way, suppose the velocity is v. Right. If the two balls collide at time t at a point above the ground, right? Right. The first one is also a ball, no? Not a bomb, right? So then, suppose they collide this way at a point. At time t only this happens. Right. So then I take to this point the horizontal displacement as d, and here this vertical displacement I take as s1, this as s2. Then s1 plus s2 is equal to h. Right. So then we can apply horizontal motion, considering the horizontal motion, s equals ut. For this and this, the same distance, this moves with velocity u with the time t. For this one, same distance horizontally, horizontal velocity is v cos alpha times t. Then we can see this d is d equal, no? Ut should be equal to this. Therefore, you can write ut product should be equal to v cos alpha times t. T and t can cancel down. Then v cos alpha is equal to u. V cos alpha is equal to u. That we get. Now what we do secondly, people, for this particle, we apply s equals ut plus half at squared upwards. It moves s2, no? With initial velocity is v sin alpha. V sin alpha t minus half gt square. Let us take this as number 1. And for this, we apply downward. S equals ut plus half h square. Downward we apply. That moves s1. Its initial velocity vertical downward, 0. Then this product is 0. Half g t squared. Number 2. Now add 1 and 2. Then left hand side we get s1 plus s2. Right? Right hand side, this and this will cancel. And given v sin alpha t. V sin alpha t. S1 plus S2 total is this h. This is h. Right? Substitute for v. V means u over cos alpha. U over cos alpha into sin alpha times t. Right? Now you can subject t. U and sin alpha you can take to denominator, cos alpha here. Then h upon u, right? cos alpha upon sin alpha is t. Cos over sin is cot. Therefore, t equals h upon u cot alpha. This is how we take it. Right now, that way we can take that answer. Number 8, relative to acceleration part. Right, we'll draw the diagram there. Right. This is mass m, weight mg. This also m mass, weight mg. Right. This is lambda m. Lambda mg. Normal reaction, suppose S. Here on this normal reaction coming, suppose R1. Here also normal reaction coming, suppose R2. Right. There's a tension in the string. This way, this way, this way, this way we can mark it. Here also the tension T available. Right now what happens, people? Once this particle slides down along the face, wedge is moving to this direction. Suppose acceleration is capital F. And this particle moves. This is moving down along the plane. Suppose with acceleration F relative to wedge, then this end should move with the same acceleration leftward, because it is joined by the same string. Okay. Now we can write acceleration of this relative to earth. What? Acceleration of simple m relative to earth, moving this way with velocity, acceleration F, and leftward with acceleration capital F. We know this angle given us as alpha. That is this angle alpha. Correct, no? This F is along this direction, no? Then this angle alpha. Right. And this will have the acceleration, other one, right? This particle will have the acceleration, simple F and capital F sum this way. This way, right? Right, now what is asking? Asking, yes, write down the equations required to find the tension in the string. Right. We can write F equals ma to this. F equals ma, we apply number 1 for simple m down along the plane, this direction. What is that? If this is alpha, the component of weight along the plane down, mg sin alpha. Upward force is T. Mg sin alpha minus T is equal to m times along this direction the acceleration. Here this is F. This is alpha, this is also alpha. minus f cos alpha. F minus simple f minus capital F cos alpha. Number 1. Secondly, for other simple m, we apply leftward. Cos is t equals m times its acceleration relative to earth. Here is f plus f. Number 2. Correct, no? No. Whenever we apply f equals ma, the acceleration should be relative to earth. Third one, people, for the system. For the system, leftward. System means wedge, this particle, this particle. Then you know this T going to be internal forces, they cancel off. Mg, lambda mg vertical force, S also vertical force, no horizontal component. And this R2 and this R1, they are internal forces. Internal forces mean another R1 coming to this wedge by the particle. That R1, this R1 cancel off. Another R2 coming to this wedge by this. That R2, this R2 will cancel off. That is why we say the internal forces cancel. Then for the system, no external force, 0. Then right hand side we must write sum of the product of mass and acceleration. First one is the wedge, lambda m f, this particle, simple m, acceleration is f plus f. The next one, equal what? The other particle, this, its acceleration, capital F minus simple f cos alpha. Number 3, right. People, among these 3 equations, see how many unknowns are there? T, simple F, capital F. Right? In these 3 equations, the 3 equations involving only 3 unknowns. 3 unknowns. Tension T, simple F, capital F. 3 unknowns. We have 3 equations involving these 3 unknowns. Then by solving them, we can find T. Right. Next one, number 9, the vector question. 9. The position vectors of the points A, B, C respective to the origin O given. O here, here A, here B, here C. O A vector given 3i plus j. O B vector 2j. Then O to B vector. O C vector given as minus A plus 1. Minus A plus 1 I plus A j. 3i plus 4j 2j minus A plus 1i plus aj. A positive given. AOB angle asking. Right. People, OA vector, we know 3i plus 4j. Then what is the OA vector modulus? Square root of I coefficient squared plus j coefficient squared. 5. OB vector is 2j. Then OB vector modulus is 2. Right. Now we can write this way. Asking to write AOB angle as this, no. Let us take this angle as theta. I write this way, people. OA vector dot OB vector. How to define dot product? OA vector modulus into OB vector modulus into cos theta. Right? Right. I substitute for this OA vector 3i plus 4j. OB vector 2j. OA vector modulus is 5. OB vector modulus is 2 cos theta here. You know here, when you take the dot product, we have to multiply I coefficients and JJ coefficients. But here we don't have second bracket I, then only 4 and 2, 8. We have to multiply. 5 into 2 cos theta. 2 and this you can cancel down. Then cos theta equals 4 by 5. Theta is cos inverse 4 divided by 5. Next one. If AOC angle is pi by 2, find the value of A. AOC pi by 2 means this is 90. This vector and this vector, people, perpendicular. You know, when two vectors are perpendicular to each other, dot product is 0. Right. Then we can write OA dot OC should be 0 because two vectors OA and OC are perpendicular if that angle is 90. OA 3i plus 4j dot OC minus A plus 1i plus AJ should be equal to 0. Right. We have to take dot product. How to take II coefficients we have to multiply. What do you get there? Minus 3 times A plus 1. This and this you have to multiply. JJ coefficient OA should be equal to 0. Right. Then we get here. Here 4A, here minus 3A. It's A. Here minus 3. When remove the bracket, take the right hand side. Then 3. A is plus 3 coming, no? Right, the question number 10, the last question. A uniform rod of length 2A, right? Mass same, smoothly hinged at A, yes, this way, right? Here we have a lamina, circular lamina. Right, no? Here it is hinged. A. This angle given as 60 degrees. And this point of contact given as C. Here people, this lamina has the mass m by 2. Weight acts through the center. Center of gravity is at the center, geometric center. By this wall, a reaction come in that passes to the center of the lamina, this way. It is perpendicular to this, right, surface. Suppose R1. And this rod gives another reaction to the lamina that also passing through the where? Center of the lamina. Suppose R2 that is perpendicular to the rod. Correct, no? Now people, let's mark the forces acting on the rod. Right. Then Rod has length 2a. A to C length given as 3a by 2. Then the center of gravity should be somewhere here of the rod. Uniform rod, no? Mass is m, weight, therefore mg. People, now here at the point C, this R2 acts on the lamina by the rod, no? Meantime, onto the rod by the lamina gives the same R2 in the opposite direction. Because you know, action and reaction take place simultaneously, equal opposite. So therefore, the red forces, of course, act in on the rod. Then another R2 acts on the rod in the opposite direction of the black R2. And here, people, a force coming to the end of the rod which is perpendicular to this surface this way. Suppose that is S. Right? S. This is a force diagram. Right. Now this length A to C. Given as 3a by 2. And people, here at the hinge A, there is another really reaction. I'll mark like this. That we are not going to find because we take the moment around A. We need to find this S. Right? We need to find this S. Right. Now, we can find this S like this. Okay. You know this is 60. When I draw horizontal line here, this should be 60. When I draw, this is 90, no people? This is 90. Then this angle should be 30. This angle 30. For the equilibrium of the lamina, for the equilibrium of the lamina, we resolve forces upwards. What do you get? Here 30. Correct, no? This is 60, this is 30. Then R2 sine 30. R2 sine 30. Equal to downward forces. This R1 horizontal not giving any force. mg by 2. Sine 30 is half, people. Then you can cancel down like this. R2 is mg. Okay. Now what we do? Now we take moment around A for the equilibrium of the rod. Okay? Right. Now we can take for the rod. We take moment around A this way anticlockwise. Then this S gives anticlockwise moment, whereas R2 and mg both give clockwise moment. Right. S times, when we produce this way, people, the line of action of S, and when we drop a perpendicular to that, this perpendicular height only we need. That means this height, no? It means this is 2a, this is 60, 2a sine 60. S into 2a sine 60. Correct, no? 2a sine 60. mg, clockwise moment. mg, right, when you produce this way, this length. This is a uniform rod. Whole length is 2a, no? Therefore, from here to here, a. When we drop this way, this is the length we need. This is a, this is 60, a cos 60. This R2 perpendicular to people, the rod. Then moment of R2 clockwise, length is 3a by 2 AC length. Right. Now, A you can cancel down. S into 2 sine 60 root 3 by 2. mg cos 60 is half mg by 2. R2 also mg, people, 3 by 2. Then we can cancel down this 2 and this 2. Here mg, 3 mg, 4 mg. divide by 2, 2 mg. Okay. Then we get root 3 s equals 2 mg. S equals 2 over root 3 mg. Right? This is how we take that reaction. Okay. Right. So then people, we meet next day in the next step. Right?